Let's start now. So as yesterday we have seen how to configure this 1200 PLC, right? Now today we see some instructions just like we are done in schematic manager. Here also you can see all the options are given in the same window here. Okay, and that side you can see the instruction list. Now in general, what it is having same new network, empty box. Okay, empty box means if you take this box, you can select the instruction from this list. Okay, like you can extend whichever instruction you want, timer and no NC. So all the list will be displayed here in this box. So whichever you want, that you can select from this. Okay. Generally, how we take is by finding the instruction and take the instruction. Okay. If you are aware of the instruction, directly T on timer. Okay, these are simple instructions you can easily select. Now, after general, we are having bit logic operation, just like in schematic manager also. We are having the similar instructions. I just change this to NO here. Now, here we are having not condition, right? Same operation. Okay, that means when you save and download, okay, it's not detecting the module. Go online simulation, start the simulation first. Load. Start all, finish. And minimize this. Then motor online. You can see input is off, output is on. If I right click and modify this to 1, so reverse, right? So similarly, we are having other instructions like output coil. Okay, and there's a one more coil here called negative coil. So here I can change this instruction from here. No need to delete and change. Just select this corner. Whichever instruction you need, you can simply select the instruction. This is a not coil. Okay. Instead of using this not, I can use a direct not output coil. Okay. This operation also same. Check in runtime. You can see input is on. This output is off here, right? It is showing dotted line. Now when I right click and modify to 0, input is off. Now it is showing on. Okay, it's a reverse condition. Okay. Like this, we're having this additional instructions here compared to schematic manager. And for checking set and reset, same thing, S coil. Okay, this one already we are done. So one input and one reset coil. So M0.1. Here U0.0. Same output we have to reset, right? And we see the another instruction. One input. Here you can see we are having set BF. Okay, set BF means set bit field. It's like if I want to make multiple outputs on and off. Okay, multiple outputs off. For that also you can use set and reset BF bit field. So M0.2 0.3. So here for set bit field, like I give the address, starting address Q0.1, and I want to make some 5 outputs on. So I'll give 5 range. I can set the range of outputs you want to set at a time. Okay. Similarly, we can reset them using from the same starting output. How many? 5 outputs you have to reset. Okay, that range we can set in BF in bit field. Okay, that's a additional instruction we are having here. Now I operate this is already on, set to 1. If I give this input, modify to 1, the output is reset. Okay. If I give this input, okay, this is on. So modify to 1, and you can see it is going off 0. Similarly, you can see this instruction here. If you give the input, modify to 1, reset all the 5 outputs on, modify to 0. Okay, it is showing green. Okay, it always shows green. Okay, but to check the output status, you can check in the watch table. Here, just like a variable table in schematic manager, we are having watch table here. So you can see the left window, we're having watch and force tables. So double click open new watch table. Here you can enter the addresses you want to watch, like Q0.1, Q0.2, Q okay, Q0.4 and Q0.5. So here to monitor the status, here also you have to monitor on. All are showing true. Okay. Now in main window, I give the reset BF. Okay, modify to 1 and modify to 0, and like a push button. In watch table, you can see all are false. Okay, here you can see the status. If you want to see that here also, I can modify. What is the address? M0.3, right? Sorry, M0.3 and M0.4 for reset. Okay, so you can modify M address, right? So I give the value M, modify 1. Here you can see this status here. This is called modify variable. When you click on this, it has made true. Okay, so what's the address for this? Oh, sorry. It's M0.2 for start. We 0 again, false, and modify. What is I change this to 2? Then I need to make it 1 and modify variable. You can see all 5 outputs are on, and even if you give false, input false, all the outputs are still set to 1. Okay, so here I make it 1 and modify. Not modified yet. Okay, all are false. Okay, this is true, all are false. Now 0, modify. So like this, you can change these values here. Okay, that's what is happening in the set bit field. Means range of outputs. Okay, like if you want 16 inputs or 16 outputs on at a time, that range also you can give continuously in a range. Okay, in array, all the 16 outputs will be on. Like this, you can set a output range here, how many outputs you want to set and reset. So that is about the set BF instruction. Similarly, just like we have seen SR and RS instruction, these are also same. So take this coil and I delete other. Now here I take SR. Okay, so M1.0 something. A temporary bit we have to give here, and here M0.1 ampere. Okay, similar instructions here also. It has been easier that you can select the instruction. Okay, that's the advantage here. The remaining operations are same. Okay, is set to 1. If you reset input, it will reset to 0. Okay. Similarly, we have P and N, positive edge and negative edge, as a input contacts and coils. Okay, and in terms of blocks. Okay, so like if I take P, this I can connect here, or you can select from here also. Select this P because it is a NO input contact. Okay, so I'll make this one, but here we have to give some memory address for temporarily storing the status of this input into this M1.0. Instead of M1.0, M0.0, we have to give I address. Okay, because on simulator I address we cannot operate, so that's why we are using M0.0. Okay. Now what is this positive edge is doing? It is creating one pulse. Okay, one shot for this. You can see one small blink in this, and I click and modify to 1. Okay, one shot, one blink, you can see that's it. Okay, it's not visible here. So what we do is to understand this, I'll select this coil as a set coil. If it is a normal coil, you cannot see the status. Okay. Online. No. Right now, the output status is off, right? If I give this 1, this input 1, you can see one shot has been given to the set input or output, sorry. Okay, this is showing green, means your output is on. If I make this off, right, there is no pulse here, right? So we have to reset. That is a reset. You see that? I will take one more network. One network. Here it is now showing the network, right? So from general, what you can do is whichever instructions you are using, mostly using in the programming, you can simply adjust here. Okay, you can like drag this new network option and add it here. And directly when you click on this, it will add one more network. Okay, so what are the instructions you are using, like timer, not, set BF, all these instructions you can add here in this block so that you can easily select your instructions. Okay, there's the advantage here. Like negative edge. So M 0.1 and M 1.1. Here I take reset coil. Save it, download again. Alter. So when you give the input here, anything happens? Nothing. Okay. So negative edge means when the input is going off. That means I have to again modify this input to 0. Then you can see that reset coil will become off. See, positive edge means when the input is becoming 1, then it gives one short, okay, to the set coil. Negative edge means when the input is going off, for that it takes one short, okay. So that is giving to the reset, okay. For understanding, we are using set reset coil, okay. Now we are having different formats, okay. These are like inputs, and there are some like PN as a coil which has inserted in middle, okay, just like in schematic manager they are inserted in the middle, okay. One in normal input coil we have to give, and now and here we have to give the address, okay. This will come here in the last. And temporary bit we have to give here always. This is the order, okay, for storing temporary status of this input, okay. So like this we have to take these instructions here. These are the different methods, okay. Some additional instructions they have given in TIA portal, and for S7-1200 we are having timers, okay. You can see we are having TP, T on and T off, and TON R. R means return to timer, okay. So these 4 timers have been given here. In schematic manager you can see there are 5 timers, okay. So TP, that's your pulse timer, okay. Here it is pulse extended timer. So whenever you drag and drop this timer here in 1200, it takes DB address for the timer. IC standard DB address it will take, okay. So just keep it to automatic and select OK. Automatic this takes the address, so no need to give T0, T1, T2 order here, okay. If you need to generate any address, okay, you have to take one timer block, it generates one address DB1, DB2 like that. So that address you can use, okay. Now for giving delay, okay, this is your start input, right? PT means your preset time, means delay time. So here you can set the order like T shift hash. If I want 10 seconds, 10s. In schematic we have to give S5 T hash, but here we no need to give S5 T hash, just give T hash 10s, okay. ET means estimated time. Estimated time is like remaining time, okay. How much time is estimated or remaining, that you can monitor. So Q 0.0 here. If you want to use the timer done bit, okay, so DB1. So what you can do is you can take one input here and one output, double click, select here. In the list it will show you the timer. I see timer 0. Just select this timer address. Then it is asking as input or output, which one you want to use, input or output. You have to use output, right? So select output of the timer. So dot Q is coming, right? It's showing the address as dot Q. Then we can give the Q0.1 other address. This is a TP timer, that is a pulse timer. Okay, save it, download. But if you are working with 300 or 400 controllers, okay, you can give the timer address as T0, T1, T2 like that. Okay, in the same order. But for 1200, it will take a DB address. Okay, by default, it will take a or generate an address here. Okay, now, so whenever you take this timer block from here, it will take this address automatically. When I right click and give the input, modify to 1, timer output is on. It is like a pulse timer, means your output goes on and remains on till the 10 seconds, and after 10 seconds it goes off. That's it. So here if you make it off, input is off. Okay, now I again give the input. Before 10 seconds, if I again remove the input, even the input is off, the timer is still running, and after 10 seconds only your output is going off. So it is like a pulse extended timer of your semantic manager. It has not given any pulse timer because operation is almost similar, but it is computing the time here. Okay, so only one timer has been given here, TP. In semantic manager we are having two timers, right? Pulse timer and pulse extended timer. Now if you want to change the timer, from here also you can change. Okay, you have to select at the corner of this timer T on for on delay timer. You can check these timers, okay, one by one. On delay means after delay your output goes on. So right click here, modify 1. See, when the input is given, timer has started. After delay, the output goes off. Okay, it goes on. If I make the input off, it is set to 0. Just like on delay timer. If you see ONTR, for this we have to give reset input, right? R is provided here. Same operation. Modify to 1. Timer has started. Okay. Even if you make the input off, it is still remaining on until you give the reset input. Okay, so there are different timers we are having here, right? For off delay timer, same thing. So when you give the input, the output is on, right? The timer is running. No. When this will run, when the input is off, modify to 0, then it starts. After delay, it makes the output off. Okay, so these are our timers. Okay.